In 1937, a massive airship filled with hydrogen gas caught fire and burned completely out of control in the sky. Yet today, we happily hand that exact type of floating object, a balloon filled with a lighter-than-air gas called helium, to children playing at indoor birthday parties. Hydrogen and helium are both incredibly light gases. To understand why one bursts into flames while the other is perfectly safe, we must look close up at a microscopic game played by every single atom. The massive physical events we see in the real world, like an explosive fire or a floating toy, are entirely decided by an invisible numbers game happening out of sight. Every atom has a center surrounded by moving electrons. Think of the outermost ring as a seating arrangement with empty chairs. The ultimate rule for stability is every atom desperately tries to collect exactly 8 outer electrons. Filling all 8 seats is how it finally rests. This vintage periodic table of the elements can actually be read like a massive matchmaking board. Those Roman numerals at the top of the columns reveal exactly how many outer electrons every element in that vertical line possesses. Knowing an element's column perfectly predicts how aggressively it will behave as it tries to reach that magic number of 8. Take the column on the far left side of the board. Because they are in the first group, these elements have exactly 1 electron sitting alone in their outer shell. To get to 8, it is much easier for them to completely abandon that single extra piece than it is to try and find 7 new ones. Because they are so desperate to discard that single extra piece, they will go to extreme lengths. If an element from this group, like a solid chunk of sodium, were to hit the water, it will react violently, sparking and sizzling just to get rid of that 1 electron. Now look over at group 7 on the right side. These elements already hold 7 electrons. They are missing exactly 1 piece to complete their perfect set of 8, meaning they will aggressively steal an electron from anywhere they can find it. This creates the perfect atomic match. A group 1 atom meets a group 7 atom, and it physically hands over that single piece. Suddenly, both atoms have perfectly completed outer shells. A violent chemical reaction happens because 2 unstable atoms are trading electrons to mutually solve their numbers problem. The large middle block of the table is made of metals that have a deep bench of extra electrons. Because they have so many electrons in reserve, they use a completely different survival strategy to find stability. Instead of finding one specific partner, metal atoms pack together and release extra pieces into a shared space. This creates a fluid sea of electrons. Free from any single atom, they drift and flow entirely through the structure. When an entire sea of charged pieces flows together in one direction, that continuous movement is exactly what we call electricity. We see the results of this communal sharing in our everyday lives. This spool of copper wire is a brilliant conductor, precisely because its atoms are built to share those electrons so easily. The metal lines that carry power to your home work perfectly because, on a microscopic level, these atoms chose to pool their extra pieces together. Finally, look all the way to the far right column of the table. These are known as the noble gases. If you count up the outer electrons for this group, you find they already possess the perfect magic number of exactly 8, or, in the unique case of helium, a perfectly full smaller shell of 2. Because their outer seats are completely occupied, they have absolutely zero incentive to give away, steal, or share pieces with anyone else. They have already won the game. As a result, they completely ignore the chaotic chemical trading happening all around them. You can place them next to the most desperate, unstable elements, and they simply won't react. Possessing a mathematically perfect, completely balanced outer shell results in a physical substance that simply refuses to participate in any chemical reactions. We can now look back at that exploding airship and the safe birthday party balloon and understand exactly what is happening beneath the surface. The hydrogen inside the airship sat on the far left of the board. It had just 1 lonely electron, and when it found oxygen in the air, it reacted explosively to finally stabilize itself. The helium inside the children's balloon sits on the far right. Its shell is completely full, meaning it is mathematically satisfied, perfectly inert, and entirely safe. You can read the entire periodic table as a precise map of atomic desires, showing you exactly what an element is willing to do to find balance. Every physical event in our world, from a catastrophic fire to the electricity lighting your room, is simply the result of atoms trying to reach the magic number 8.